Hey there, we're going to start talking about 3.3, which is a continuation of quadratic functions and equations, but we're going to introduce a new set of numbers, and this is called complex numbers. We're going to talk about complex numbers by starting out with the unit I. I is now a number. What? Who knew? A letter could be a number. But in this realm, y'all know how we always say the domain is all real numbers. My question was, well, why are we saying all real numbers? Like there's not real numbers. And in fact, there is a set of numbers that are not considered real. They're called imaginary numbers. So imaginary numbers, oh, I'm just butchering that. I wonder if I spelled that right. Imaginary numbers are basically when you take the square root of a negative. So y'all know how we always say, no taking the square root of a negative. Well, if you do take the square root of a negative, then we have to include the set of imaginary numbers, because in the real world, you can't take the square root of a negative. Like -1 times -1 is equal to +1. 1 times 1 is equal to 1. So no matter what you do when you square a number, you're still going to get a positive value. So when you take the square root of negative, we usually say does not exist. Until today, we are going to say, you know what? Let's give it a definition. The square root of -1 is actually going to be I. So anytime you take the square root of a negative, you're going to introduce this I. Okay. So of course, throughout history, people have invented or discovered new numbers to solve and describe equations. So like if we look at this equation, x squared plus 1 equals 0. X squared plus 1 equals 0. There are multiple ways for us to solve this, like we learned in 3.2. But one way to solve it is to just, because there's only one term with x's in it, we can use the square root property. So we get x squared equal -1. Well, then to undo square, you take the square root. Well, we can't take, so the square root of x is, x squared is x. And the square root of -1, we usually say that doesn't exist, but now we're actually going to say it's equal to I. Okay, so let's do that again. Let's do it by looking at what the textbook has for us to think of in this case. When we isolate the x squared, we apply the square root property. We get x equals plus or minus the square root of -1. But because the square root of -1 is I, we have plus or minus I. So when I did it the first time, I did forget the plus or minus. Don't forget that when you take the square root of something, you have to consider the positive and the negative. Because negative times a negative is a positive, and also positive times positive is a positive. So graphically, we can see that y equals x squared plus 1 never touches this line. So when can it be equal to 0? It doesn't equal 0. This is the line of y equals 0. So therefore, we know that they're not real numbers that actually allow that to be the case. It has to be a complex number or an imaginary number, a non-real number. And in this case, we call it plus or minus I. So do not get all frustrated or scared about this. Literally, it's just a letter that we've now introduced that allows us to take the square roots of negatives. Okay. So we know the square root of 16. So we're going to look at this as if it's -1 and the square root of 16 separately. Okay, so we separate the -1 times 16, and then we say I, and we say 4, and we get plus or minus 4I. That's how you write that. But let's look and see how the textbook does it. Again, we separate the two, and it's 4I. I would say plus or minus 4I, because we do have to consider the positive and the negative. So plus or minus 4I. Over here, you have square root of 12 times the square root of -1. Well, 12 can be broken down into 4 and 3. And we still got -1. So this is 2 root 3 and I. The square root of 3 is not a whole number, so we leave it as a radical. The square root of 3 is not a whole number, so we leave it as a radical. So you're going to say 2 and I. Since those came out of the radical, we put them in the front, and the square root of 3 goes in the back. Again, I would still say plus or minus. So yeah. Moving forward, we got -2 plus or minus the square root of -36 over 6. Well, the square root of -36 is equal to plus or minus 6i. Okay, so that's going to be -2 plus 6i over 6 and -2 minus 6i over 6. And I got the 6 because the square root of 36 and the square root of -1. That's how I got 6i. Okay, because the square root of 36 is 6. So then we continue. All of these are divisible by 2. So if we reduce it, this becomes a 1, a 3, and a 3. The 1/3, you could, it's the same thing right here. But you could look at both of these separately. -1 over 3 plus 3i over 3, which gives us -1/3 plus I, because the 3's cancel. The other one will be -1/3 minus 3i over 3. I just split the fraction so that they each could have a denominator of 3, because that's what that long fraction bar means. And so I'd have -1/3 minus I. So that will be my answers. So let's look at this again, but from the standpoint of the textbook, and see what we come up with. Okay. So they just separated just like that and then put them back together. -1/3 plus or minus I, which is the same thing as this. Okay. Write your answer in standard form because we're going to solve this. So let's solve it. We can take the square root of, we're going to divide by -4 first. Well, actually, this has us doing it a little different because it says write your answer in standard form. So we're actually starting by writing it in standard form. So we're moving that 3 to the other side. Or the 4x squared together. Sorry about that, y'all. Okay. Then we use the quadratic formula. So we say, what is A? What's B and what's C? So A is 4, B is 0, C is 3. We plug them into the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. And so that becomes -0 plus or minus the square root of 0 squared minus 4 times 4 times 3 all over 2 times 4. Okay. So then that becomes 0 plus or minus the square root of -48 over 8. Square root of -48, we're going to have to reduce that. That's 16 times 3 times -1. So it's going to be 4i root 3 over 8. And when you divide everything by 8, that first term is still 0. Okay. The 4 and the 8 cancel to be 1/2. So that's going to be I over 2. And that's how we get it. Plus or minus I root 3 over 2. So let's do this again. Square root of 40, square root of -48. Best way to think about this is to break that 48 down into 16 times 3 times -1. Well, we know the 16 is 4, square root of 16. The square root of -1 is I. And this square root of 3 just stays. So I have 4i root 3, and that's divided by 8. Remember, we had this 0 divided by 8, but we know 0 divided by anything is 0. So you still have 0 plus or minus. The 4 and the 8 cancel, we get 1 over 2. So this becomes I root 3 over 2. Because we have that 0, we don't have to write it. So we're just going to have plus or minus I root 3 over 2. Okay. And we could have solved it using the square root property like I first started out. So let's look at that way. Okay, I'm going to actually go backwards. So in this way, you're going to divide by -4 first, because again, you can only use this property when you only have one term with the x in it. Divide by -4, and then take the square root. And the square root of the top, you're going to take the -1 and the 3 out, and the square root of 4. And so that becomes I root 3 over 2. Same thing. You could choose to do whichever one you want. The reason why we can do either of these is, again, because it's only one term with an x squared. Here we cannot do the square root property because there's two terms with an x in it. So we have to use the quadratic formula. So we're going to use a quadratic formula and say, what is A, what's B, and what's C? A is -2. B is 1. 3 is -3. C is -3. So then we plug that into the quadratic formula, which is x equals -b plus or minus the square root b squared minus 4ac all over 2a. So x equals -1 plus or minus the square root 1 squared minus 4 times -2 times -3 all over 2 times -2. When we simplify this, we get -1 plus or minus the square root of 23 all over -4. I highly suggest you use your calculator to just type these in, and then the calculator will actually solve them for you. Actually, let's show that real quick. Okay. Let me try different. Let me share my calculator. Okay, so I'm gonna second plus 712. Actually, let me get out of this app that we were in class. Okay, so in this, I'm gonna say alpha y equals, and I'm gonna try to type in the quadratic formula just like I saw it. So it'd be -1 plus, you can only do one at a time, the square root of 1 squared minus 4ac all over 2 times a. Oh my gosh, it's telling you there's non-real answers. That means that there's a complex number. So what I'm going to do is I'm going to go to mode. And I think I can turn this down here. Right here is blinking real. Next to it, that's called an imaginary number, that a plus bi. So I'm going to enter that, and it's going to start blinking now. So when I go back to my problem, now I get to see the imaginary number. The problem here is that this decimal is here and it's not an exact number. So if you want an exact number, you will have to reduce, but at least you can check your work in this way. So let's go back to our slideshow. Okay. And we're going to reduce. See, the square root of 23. 23 is a prime number. So there's no factors of it. We'll just have square root of 23i, or I square root of 23. And you still have the -1 and the -4. And so when you reduce that, you'll get +1 over 4 plus or minus -I root 23 over 4. because you have a plus or minus a negative, it doesn't really matter. They're all going to become still a plus or a minus. Because plus or minus is now a minus, and minus a minus is now a plus. So you still gonna end up with a plus or a minus. Okay, that's how we get from there to there. Okay, and that's the answer. All right, example number 4. Use the graph to predict the number of real zeros and the number of complex zeros, then find the zero. So because it doesn't even touch this line of y equals 0, there are no real zeros. So we know that there's no real zeros. And now we have to predict the number of complex zeros. I believe there might be 2. So let's check it out. Because the function never intersects y equals 0, there's no real solutions. That means there are 2 non-real complex solutions or zeros. You also know that because the discriminant is negative. The discriminant is that square root part, b squared minus 4ac. If you just do that and you find it's negative, you know that when you take the square root of a negative, it's not going to be a real number. So therefore, it has to be complex or imaginary numbers. Complex numbers are in the set of imaginary numbers. Okay. So then it says, just go ahead and find them. So we're going to use the quadratic formula. We're going to solve a equals 1, b equals -2, and c equals 3. Okay. So once we solve this, we get 2 plus or minus square root of 4 minus 12. So 4 minus 12 makes -8 over 2. 8 can be broken, -8 can be broken down to 4, -1, and 2. So that'd be 2i root 2. So 2 plus or minus 2i root 2 over 2. All of these 2's gonna cancel, and we're just gonna end up with 1 plus or minus the I square root of 2. There we go. And you can see that because you can divide everything by 2, and 2 divided by 2 is 1. Okay. So there are 2 non-real zeros, and there they are. We're gonna do this again. So we're gonna predict it. Looks like it touches the y equals 0 one time. So there's one real answer, and maybe there's one complex answer, or maybe there's just one real answer. Let's check it out and see. So there is one real solution, and we see that because it touches. And because it touches at 3, we know x equals 3 is the solution. There are no real non-real complex zeros. So if it has real zeros, then it doesn't have any complex zeros. So there's only one number that will solve this, and it's x equals 3. So yeah, if you were to plug in 3 for x, would we get 0? So let's see. 9 minus 18 plus 9 equals 0. 9 minus 18 is -9 plus 9 equals 0. Yes. All right. So there are 2 places here. And it's going to be at x equals -1 and x equals 3. So we're really looking at this line to see where does it cross. And those are going to be your results or your answers. So 2 points, 2 real zeros. The discriminant was positive this time. And we can see graphically that they cross at -1 and 3. Note, if you're only given the equation but asked to make observations about the graph, first find the zeros and use those along with leading coefficients to sketch the graph. That's it. That's all. Thank you for watching 3.3. Be on the lookout for 3.4.